This is the Azure guy, and today we're going to talk about cloud services, Windows Azure internals, load balancers, DIPs, dynamic IPs, SLBs, the software load balancers, and about load balancers. Hope you enjoy. Thank you. Hey guys, let's start on cloud service. So basically, before going to the cloud service, let me repeat what were the previous videos which we looked into. Like we learned about what exactly how exactly the service, like the instances are created or virtual machines are created on top of what host services they are created, and where exactly these host services are located. And now we will be taking out some great examples over the internet, and I'll be describing about what are the cloud services, okay, and we'll go through Windows Azure internals, how the cloud services or the instances are allocated inside Windows Azure DC, and we will go and read about we'll know about load balances, we'll know about dips, and we'll know about SLBs. So when we talk about affinity groups like affinity groups are nothing but you can see that this is complete DC architecture, the DLR architecture you can say of Azure DC. So you have access routers at the top of the DC, and you have aggregate switches. So switches are nothing but it's a networking device which routes traffic across the underlying devices. It can be servers or it can be racks of servers. So under the aggregate switch, we have a huge number of server racks attached via Tor switch. Okay. So when we talk about uh, when we create a cloud service, I'll let you know what exactly is a cloud service. And for just now, you just think that cloud service is a service. Like when we create a VM, you'll get a container called as cloud service. Okay. So let me give an example of a cloud service which we have created earlier. So here you can see we created a virtual machine. So we just created a virtual machine. We went and quick created virtual machine, quick created from gallery. But we didn't say that need any specific cloud service. So the virtual machines which we have created would be part of a container called a cloud service. Okay, and you can see that cloud service here. This is a DNS name. This is a DNS name. That's a cloud service name. You can see in the old is in the new portal, and then go to the properties section. Here as well you can see the DNS name, which is the cloud service name, the azureguide.cloudapp.net. So this have a virtual IP, this one, and it have a private IP and a VIP, and this is a dynamic IP. So cloud service is a container, and it has uh, defined. So you can go that this here is a cloud service. You can go to the cloud service. Whatever the VM instance, VM virtual machine we created, and this is the URL, the cloud service URL. Inside the cloud service URL, we have a single instance of VM we have. Here is the VM, and VM is here the input points, and this cloud service IP and this virtual IP are the same. So whatever IP which we have for the cloud service is nothing but a VIP for the VM instance as well. So whatever traffic comes to the VM, it gonna come via public VIP address. Here is the important endpoints we have for partial and for RDP, for the port numbers. Here's how a cloud service looks. So when you create a cloud service, like uh, the services which the instances or the VM instances which need to be created are basically when we say affinity groups are like affinity is proximity, like how much proximate our compute our services. Like I create a cloud service, so or I create a VM, I create a cloud service, then I'll get a compute and a storage account also I need to create because the VHD goes and sits there. So the proximity of this particular compute and the compute capacity, the VM and its VHD, wherever it's at, because it continuously writes into the VHD. It reads and writes onto the VHD, the compute, the VM. So they need to be very near. If they are not near, like for example, if your compute is somewhere here and the storage is and your storage is here, okay, and the regions of these two, and the green colors are storage racks and these are compute racks. Storage racks are far or in a different region than this, than the traffic which carries out the read rates, which would be, whenever you log into a machine, you do some activities, that read rate happens. So the read rate need to go from this particular blue aggregate switch to across the storage. So it need to travel from you east to west kind of traffic scenario. So if it's one VM, it's okay. If it's thousands of VM or 10,000s of VMs under a particular server, and every read and write need to travel from east to west from compute to the storage, then it would load onto the aggregate switch. So in order to avoid these things, we have such something called as affinity groups. When you mention an affinity group, that a particular cloud service or storage account need to be affinitized, then the Azure makes sure that the services or the instances or the storage clusters which they will create, they'll go and sit nearby in the same DCs or same region, so as to avoid the amount of traffic flowing through the DCs or through the aggregate switches. So you can see Affinitized Cloud Service is deployed to the same fabric cluster. If cloud service, you say that if two cloud service you are creating and you say that they need to be affinitized, then they would sit in the same fabric cluster. If it is a storage account, it would be in the same region. And if it is a cloud service and storage account, it would be deployed in the same region. Like this green, the first rack, green color rack and the blue color rack would be in the same region, and your cloud service and storage accounts would be sitting in the same region. So that's what is affinity groups. So coming down to the cloud service, I said it's a container for virtual machine. So here you can see in the diagram. So cloud service is a containing the VM. So you can have multiple number of VMs. The IPs of it can be tagged to cloud service VIP. So cloud service is a public IP address. So it will give a public endpoint. Public endpoint it gives, and it has a public DNS name. It has internet firewall. It has a load balancing method, or it can act as a boundary for a virtual machine. So basically cloud service is like it's kind of PAAS alternative for VM, virtual machine. VM are IaaS services. Virtual machines are IaaS services, whereas cloud service is a PAAS service. So it is a sort of shared computing resource. When you say about shared computing resource, like the host contains of multiple of instances, and or a single VM maybe host a single VM may host multiple number of instances, and these instances are run on same shared computing CPU. And these instances, since they are shared, they are cheaper than procuring a single dedicated VM. So you can see in the diagram. You can see in the diagram, like whenever you procure a cloud service, you have a service endpoint from where you can interact with the cloud service. Like you have a virtual machines in it. So cloud service can have non IaaS components like worker roles, and IaaS components like a VM with IAAS installed on it. Since these being a PaaS services, so you'll have flexibility, or you can just concentrate on your application coding and configure everything, and then just give the package. The cloud service would take, would replicate, or would copy the files, your package files, into into three three different locations in storages, so that whenever while doing while uploading onto the IAS or installing into the IAS of web role, if it fails, it can get a copy from these three replicated places. So the cloud services would have, have a web role and a worker role. So web role, what it do is like it has IS, it can accept internet. So the service endpoint, whatever the customers and the users can interact to the application via service endpoint via this web role. And the web role can take advantage of background processing by the use of worker roles. And the web roles and the worker roles can consume data from storage, the Azure storage. So we have in Azure storage, we have something called as tables, queues, and blobs. We will be talking in depth about it in later part. But if we have queues or tables, worker roles can consume from these particular unrelational database. And web roles can write, our application can write onto the storage, so that it can maintain redundancy and consistency of an application at the same time. Going next, here you can see, like, I have an external client, it's my desktop, and I have created a cloud service called as my cloud service.cloudapp.net. And my cloud service have I under this particular cloud service, I have three VM instances. And these three VM instances, as we talked about UD and FD. UD earlier as update domain, and FD as fault domain. If you have not followed on to it, then you can please go back, pause the video, and check what exactly is update domain and fault domain. So you can see each VMs are placed in a different update domain 0, 1, and 2, and fault domain 0, 1, and 2, which means that when if it's fault domain 0, 1, 2, then these particular VM 1, 2, 3 are placed on a different server racks. It can be in same server, same service region, but in a different server racks. And the UD is also different, which says that they are hosted on a different host, or in a different server racks. Before going to in depth, I'll show how to create a cloud service. When you go to the old portal, you can create a cloud service in an easy way. You just go to the cloud service, you go to the manage.windowsazure.com. It's an ASM portal. Remember the ASM? I'll let you know what exactly and how it is different in the earlier next slides. So you can go and create anything. So what you will have is, after you create a cloud service, you, you will have a container, and inside the container, whenever you create a virtual machine, you remember you mention a cloud service name. So if you go next, you'll mention a cloud service name. So the when you mention the cloud service name as the Azure guy, when you'll mention the name as the Azure guy, the VM whatever you create, it comes and sits at here in this particular cloud service. And once you create a VM and a cloud service, you just go to instances, you can connect to it. You'll have multiple number of cloud services here. See, you can check the update domain and the fault domain, where exactly it went and set, so that you can you can be sure about, like, your application is sitting on a different servers. If one server fails, your application will be still up and running. You can connect to it like a normal VM. You connect to it. Let's go back to our slides. So allocation of services. So it's this particular slide I have picked up from one of the famous Azure internal video of Mark Rustinovic. So it's one of my favorite video, and it says about allocating a service, allocating how allocation of a service or a cloud service happens inside Azure data center. So you can see this is a server rack, and this is also server rack, and this is a server rack. So the person comes and create mycloudapp.net, and he says that I want three instances, role A of three instances, and there would be I want a three role A instances and three role B instances, two role B instances. So the role A instances would be of uh, should be the update domains. Update domain should be three. It should go and sit in three update domains, and the size is large, but the role B size is medium. So the, when we say about large or medium, we say about core or compute capacity. So you can see that I said that cloud service is also called as a load balancer endpoint. So whenever the traffic comes for a cloud service, that application is hosted in this particular can be hosted in this here in this instance, and here in this instance, and here in this instance. So the traffic which comes for an application, like people would be calling, if a google.com is installed on these three instances, then when the traffic comes, it can either redirect to the first server or second or third. It just depends upon what kind of load balancer the cloud services is taking part in it. And we will talk about more about in-depth load balancer in future time, but we will touch to a little bit or sample part of load balancer in the next slides. So role A comes when allocating, when you say the cloud service to create a role A and role B with this particular configuration, fabric controller goes and checks that which particular host servers are empty. It goes and checks that it goes and checks for the first slot, and it finds that the first host server is busy. Host server in the first server rack is already occupied. It's totally occupied. The black spots are occupied, and it allocates and goes to the fourth tab on the server. So it gets for role A 4 cores. It gets, since it's a large instance, and it gets 2 here in the same for the role B. So in the green is role B, and since they are medium, so they are 2 core machines, and this is being large, it's a 4 core machines. Since the count of this role B were 2, so they sits in the update domain 0 and 1, or the fault domain 1 and 2, or 0 or 1. And since the role is 3 instances, it goes and occupies 3 different server spaces. So that's how allocation of service inside a server rack happens. So when it comes to, like, when allocation happens, the allocations happens with the help of with the help of a stateful application called as Fabric Cluster. So Fabric Cluster is a distributed mechanism which take care of allocating a service across the nodes. Even if one particular fabric controller goes off, as the state of that particular thing is the state and the health of that particular fabric controller is remembered, the allocation of next services would be done in the next rack, not in the failure rack. So the requests do not drop, but the requests are carried out to another fabric controller if the FC1 fails. Let me know if you got confused here. I can I can type it again in the comment section. So if you have a doubt about what is stateful application, please read about it. Stateful application are nothing but they just, or it can be a server which actually stateful server, you would have heard like it stateful server would be like it's uh, uh, or it retains the session. So like whenever the traffic comes from the spine to the toss switch and to the fabric controller FC1, then the session session or state of that particular request would be remembered, and if next time it comes, it would be redirected to the same rack. Since FC remembers the state or when is the last time that particular request had come to FC. Going next, this is inside Azure DC. So this is one of the first type of architecture which were formed. So when I said like east-west traffic, so the traffic flows from the compute to the storage, or the reads or writes happens. So in the previous diagram, you would have saw that the traffic here in this diagram, like for the read or write, the aggregate switch, which actually that there are 20 racks under each aggregated switches. So the aggregated switches plus load balancer. So the traffics which the compute resources, if they are allocated here, if your instance is located here, then the read writes which perform or the VHDs goes and sit in some storage location. If they are sitting in some other storage locations, then the read write should go from the compute to the TOR to the aggregation to the access router to DC router, and then to the access router, and then to the west of the west region of where this particular storage is sitting, the east-west traffic concept. There is something called as east-west traffic. What it what it makes, what problem it creates is like the more number of racks. These are 20 racks. If we have 10,000 racks, then the traffic which gets induced in this particular aggregated switches can fail these switches as they are physical devices. So this particular concept or the issue was used to call as the east-west traffic. Going to the next, the architecture was optimized, and what they have done is what Azure had done is like they have the compute space, and you can see 8 HD compute racks, 7200 and 160 TORs, and there are 30,000 servers under it. But this time they have something called as uh, even you can see that 3 out of 1 over subscriptions. Like whenever subscription, when we say about subscriptions, it's about uh, onboarding a tenant for whom you can give Azure resources. The Azure resources can be virtual machines or PAAS instances, anything. Over subscriptions is like it's like loading up only a single server at a time very hugely. Like you have creation of VMs, and the creation of VMs around 10,000 VMs comes up and sits up on this particular TOR. So which can load up the store and make it unresponsive. So the spine cluster, the spine aggregate switch, what it takes care is it allocate when the request comes, it try to allocate into next bandwidth, next particular freely available servers, nearby servers, so that it won't load up to it, the spine TOR. So you can see the decrease in the total over the subscriptions. After this, they have optimized and they have bought a cluster spine on top of this particular TOR switch. Since in the previous slide you can observe that the TOR switch is oversubscribed by like the having around 3000 requests per second and overloading this particular TOR. But after that, what happens is like nearly the But after having the cluster spine, we have four talk switches under a single cluster spine. So which helps in load balancing things. And under it, we can have 10,000, hundred thousands of servers at this particular time. So this is a quantum 10v2 architecture which we have currently in Windows Azure. So the internal code, how it looks is like the whenever the request comes uh, for allocation or creation of a virtual machine or instance, the code would be like this. There would be a this is a rack server. the code would be mentioning have a rack server code, the location ID, and the network switch which is associated with it, and the server details, the power strip what is there, and the plates, and each and every machine pool or the host services which are there are mentioned here, are mentioned in this fashion way. So this is a code level things which is mentioned. And let's go and talk about a little bit about load balancers. So load balancers were there across the whole database or the data center, Azure data center. You can see the load, the TOR switches or the aggregated switches are work as a load balancers, and the huge disadvantage of load balancers, and particularly hardware load balancers, were they were expensive, and the PIPs, the public IPs which you can mention, were having limitations. If you need to upgrade or add more pips, you need to the Azure IT need to add up different or add more servers, more load balancers on it, which makes that particular network ad hoc. And hardware load balancers being the hardware the single point of failure was more. So that's why the concept of software load balancers came into concept, where that load balancing of traffic is being done with the help of programming knowledge. So here you can see that there are three particular content, external control, and data. So the fabric controller take parts, and it's a tenant manager. Tenant manager is nothing but when you create a resource, when a customer comes and says that every customer is called as a tenant in Azure terms, and a tenant manager is like it helps in locating a resource in Azure DC, or creating a VM and allocating proper credentials, and you creating a user and giving back the user with the access to that particular VM. So fabric controller and network manager, they both take part take help take help. You can see the complete flow. They contact SLP manager. SLP manager make sure that what particular hosts are available, and the host agent will talk with SLP host plugin, and SLP host plugin will get the necessary host driver and get install the whatever user would the web traffic. The web traffic is a place from where the user can make a contact, so that it will what it would do is like it will bring up the VHD, it would create a VM, it will create all the necessary drivers, and it would open the channel via the physical network device, using the help with the help of mux role or the mux agent, and it creates a VIP and then give that particular VIP to the customer. That's how with that VIP we can able to log in into the server, and we have access to our instance which we have created right now. So when we talk about the cloud service, then cloud services act as a load balancer. It acts as a load balancer because it can have a number of instances underneath, and it can balance the load. Like the instances gives health report to load balancer and says that I'm alive. Basing upon that, whatever the traffic comes to the VIP 65.123.44.22, it would be either given to account to the code. It can give to the instance 0 or instance 1. If it's not, it by default it would give or route the traffic equally to both the instances. These instances are the PAAS instances you can consider, or the VM virtual machines underneath a cloud service. So what this load balancer overhead is talking about is like whenever you go via cloud service, if you want to log into instance, you can log into by its PIP, uh, by its uh, by its private IP, instead of logging via cloud service. If you do via cloud service, then it will add up a load. Like here, it's around approximately 5 milliseconds for RDPing into the instance. That's called as load balancer overhead. Deploying a service to the cloud, it's like there are two methods or there are two mechanisms via how Windows Azure takes a service to the a service or a package to the Azure cloud service. So one particular way is like it uses RDFE method. When we talk about RDFE Red Dog frontend, it's nothing but it's like using this particular management portal. If you go through old portal manage.windowsazure.com, it will use RDFE or the ASM service to allocate a service. If you create a resource in the new portal from portal.azure.com, then that would use a new ARM service to create your services on Azure. So there are RDFE and ARM, ASM and ARM. I'll let you know what are the differences between the ASM and ARM in the later slides. So what happens, you can communicate with Windows Azure, or you can create a service or host a service on a cloud on the cloud on Azure via System Center or PowerShell or Windows Azure portal or via REST API or via REST APIs. So you go where you can create a VM via Windows Azure portal. It would create from RDFE service. It will go to the Fabric controller and it would go and your service would be created in in the data center. So here is like what happens when you create a package. Like the package is when you create an application, and there's you create an application package, and the application package, what you do when you host an application locally in your system or in your desktop, you log into the IAAS, and you in the applications tab of the IAAS, you paste the application files. The same thing happens over the cloud or in the cloud services. Cloud services, what happens is like the cloud services would take your core package, your application package, and if you're doing through Windows Azure portal, like you have a cloud service, you have a cloud service. Let's create a cloud service. Test cloud or cloud. We should try 7. Host in 7 Saint Central India. Cloud service. Cloud service is created. So you can upload. So you can see there are slots, something called as production and staging. So these are the two slots. Every IT guy who works or loads up the application onto the server, onto on his on-premise desktop, on-premise servers, he knows about the production and the staging. Production is where actual users would be hitting, and the staging would be, you can upload your application package, and the application package are in two formats. One is a package file and a configuration file, and this is a deployment label you can give, and you can mention to how many instances it go and sit. You can either the push out your application package in storage and pick up from there, or you can put it from your local or from your desktop or laptop which you are using. So this is a cloud service. It's a container, and when you say upload, you have application package. This is how what I was talking about. The application package you can put, and you are doing with RDFE since it's an old portal, and the FC Fabric controller takes it. It puts onto your host server, and it would start up. At that time, it would create. Once you do that, it would create instances like virtual machines instances. It would create, and the instances, once they create, you'll find the instances aligning up here, and then you can RDP into it. You can RDP after that. You can log into IAAS and you can check in the applications tab. You will have the same application package installed on it. Instead of you manually uploading the package into the IAAS of a virtual machine, cloud service makes your work easy, helps you concentrate on your application perspective or coding perspective. So what it do is, what are the suggestions from Azure is like, instead of uploading every time the core package from your desktop, because whenever you upload a package, it replicates into three different places. So which uh, three different storage accounts or three different regions. It it stores or replicates the your package. So if you want to retain the time or optimize the time, what you can do is that auxiliary files or the media files, whatever files you have, binary files or the package files, you can keep it in a storage or the data files in a storage, and you just pick from that particular storage, which makes it quite faster. You can deliver your application features faster to the customer, like from storage here. Going to the next is how storage package is deployed. Going to the next, hopefully we are done, and we have learned about a lot of things today, and hope you guys would have liked it, and do share this video and comment your questions. I'll be very much happy to answer them as soon as possible. Thank you.
There's turkey in the oven, the mashed potatoes bubbling, watching football with our family and our friends. We smell the food a-cooking, and Grandpa keeps a-looking. Grandma pushes him out of the kitchen again. The little cousins, they all zoom, screaming loud from room to room. We don't seem to care.